Assalamualaikum students. Students, in today's lecture, we are going to do dative bonding, right? Dative bonding, which is also known as coordinate covalent bond, right? But before starting dative bond, you know what we did in the previous lecture? In the previous lecture, we have done the shapes of molecules. The shapes of molecules. And you know what you did in the shape of the molecules? Actually, why I'm revising? Because we need to use them in the dative bonding. And when we will be using the shapes in the dative bonding, you will be able to memorize the angles and the shapes. And the summary is, if in any molecule there are two bonds and no lone pair, the angle is what? 180 linear. In any molecule, if there are three bonds and no lone, and the other case is what? One lone and two bond. Now, two bonds, 180. Three bonds, 120. But if there's one lone and two bonds, then the lone occupy more space. Bent. All four shared, four bonds. Zero lone. Three bond, one lone. Two bond, two lone. 109.5, 107, and 104.5. And other than these cases, you know, what else is there? The PCl5 and SF6. You know, PCl5. There is 90 and 120 trigonal bipyramidal, and this is just 90 octahedral. Like, actually, if you know these and you know the dotted cross, you will find the lone and bond pair and you can find the shape. Now, we are starting what? Dative bonding. What is dative bonding? Dative bonding is the bond in which shared pair of electron is donated by one bonded atom and accepted by other bonded atom. You know, it is not complete transfer of electron, not complete transfer of electron. Let me show you one thing. These are the notes. This is the topic that we are doing. These notes are available on my website, Chemistry by Zeenat, right? See, what is dative bond? The bond in which the shared pair of electrons is donated by one bonded atom and accepted by the other bonded atom. One atom is the donor of the pair. The other atom is the acceptor of the pair. So it's not complete transfer. It is not complete transfer. Look, one atom is donor of the electron pair, the other is acceptor, and it is represented by this arrow. And these are the examples which are mostly asked. Ammonium, phosphonium, hydronium, L2Cl6, and carbon dioxide. So, coming to the topic, see, so there is not a complete transfer of electron pair. Actually, the shared pair of electron, it is donated by one, it's donated by one and accepted by other, but still shared. Still shared. See, if I explain carbon monoxide first, I'm going to explain before explaining one thing. It is represented by what? Arrow. It is represented by arrow. Like the covalent bond is like this dash. But dative bond is represented by arrow from donor toward acceptor. Now, if I explain the example of carbon monoxide, you know, carbon is of group 4. It needs how many electrons? 4 to complete the last shell. And oxygen is the element of group 6. 1, 2, 3, 4, 5, 6. Now, look, it needs 2 electrons. In this way, its last shell will be complete. But after sharing 2 electrons, 1, 2, 3, 4, 5, 6, it still needs 2 electron more. See? If I make it, this is 1, 2 by carbon, and this is oxygen. 1, 2, 3, 4, 5, 6. After sharing 2 electron by oxygen, 1, 2, 3, 4, 5, 6, 7, 8. Its last shell is complete. But carbon, 1, 2, 3, 4, 5, 6. It's still deficient of 2 electrons. Now, if you look at this bond, 1 electron is donated by carbon, 1 is by oxygen. Carbon, oxygen is mutual sharing, covalent. What oxygen will do? It will bring these pairs and it will share these pairs with the carbon. So if you look at this, one pair, another pair, and another pair. There is mutual sharing, but this is one-sided sharing. The donor is oxygen and the carbon is acceptor. So it's kind of like there are 2 covalent and one is what? Dative. Oxygen is the donor, carbon is acceptor in this way. 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, and 7, 8. Both have complete last shell. This is carbon monoxide. If we look at ammonia, making ammonia, look, this is nitrogen. I'm going to explain this fully so that you can understand the charges, the everything, right? This is nitrogen, ammonia, reacting with HCl, making what? Ammonium chloride. Now, you know what happens? Nitrogen, 7 proton. This is 1, 2, 3, 4, 5, 6, 7. And this is hydrogen. This is what? hydrogen sharing 1, hydrogen sharing 1, hydrogen sharing 1. If you look at this, there are 3 shared, there is 1 lone, the angle is 107 in trigonal pyramidal. If in place of hydrogen, if I write proton, look what? A proton. So how many protons are there in this whole ammonia? There are how many protons? 7, 8, 9, 10 protons. There are 10 protons. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 electrons. They are equal. There is no charge. Now, look at the HCl. There is this H sharing electron with what? Chlorine. 1, 2, 3, 4, 5, 6, 7. This is hydrogen. You know what happens? This chlorine take both the electron, become negative. The 7 are its own electron. 1 electron is of hydrogen. So it becomes what? Cl negative. I'm making it red, right? This is Cl negative having its own 7 electron and 1 from hydrogen. It becomes -1. Now when the electron of the hydrogen is taken by chlorine, the hydrogen has no electron. The hydrogen is like this without any electron. Need how many electrons? 2 electrons to complete the last shell. Is this possible for the nitrogen to give electron to this? Yes. So it's donor and the hydrogen is what? Acceptor. The hydrogen is acceptor. The hydrogen is acceptor and this one is donor. So the nitrogen is donor and the hydrogen is accept. So how the bonding would be? Look, I'm bringing this whole thing here. And the hydrogen will share the electron with it. Hydrogen has a proton. Look, the Cl take the electron of the hydrogen. The hydrogen is not having any electron. It comes to the ammonia, repeating. Cl take its own and the hydrogen electron going this way, become negative. Hydrogen has no electron. It needs 2 electrons to complete last shell. It shares the electron with the nitrogen of the ammonia. Now, this whole become positive. Why? Because there are 7, 8, 9, 10, 11 protons. There are 11 protons and there are 1, 2, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. There are 1 proton more. As a result, it's positive. Right? So if you want to see it again, it's like this. Nitrogen of group 5, hydrogen, hydrogen, hydrogen. This is trigonal pyramidal. And this is H plus having no electron. This is H plus having no electron. So it becomes ammonium. It's like this. A dative and 3 covalent. And now it is positive and the angles are 109.5. See? Do you understand this? That how the ammonium ion is formed. The nitrogen making 3 covalent and 1 dative with H plus. There is mutual, 1 electron from one, the other from the other. Huh? There is mutual, but this is one-sided sharing. And nitrogen, phosphorus, As, they are in the same group. If nitrogen make ammonium, the same is for what? Phosphonium. Exactly the same. Now, if you see what happens in water, water with H plus become what? H3O plus. There is this oxygen. 1, 2, 3, 4, 5, 6. These are hydrogen. Now there is this H plus. Deficient of how many electron? 2, needs 2 electron. It can share a pair with this donor toward acceptor. Actually, when there is a positive charge like this positive charge shows that in this whole system, there is 1 proton more than the electrons. 1 proton. Like if there are 18 electrons, the proton should be 19, so that there are more. Like I'm just giving you example. Like even in ammonium and phosphonium, in all these, this plus indicates that there is 1 proton more than the total number of electrons. So what is happening here? It's giving a pair, making a dative bond. Initially, it was bent. Why? Because there are 2 lone and 2 shared. There are 2 lone and 2 shared, and it is what? 104.5. Now, when there is this, let me copy it from. I'm copying that, then I will rewrite it again. Like this is water. This is H plus, making a dative bond like this. This is H plus. So what is the difference? Now I'm writing this again. Giving electron. Look, this is mutual. Cross and dot, dot and cross. But this is what dot and dot. So this is the donor and this is the acceptor. Now you will ask that why there are not 2 H plus. I'm telling you, wait a minute. 2 covalent, 1 lone, 1 dative, but now the angles are what? This is what? A, B2, and there are 2 lone pairs. There's 1 lone, 3 shared. So A, B3 with a lone. So the angle becomes 107 trigonal parameter. Look, this is water. These are 2 lone pairs. They're very close. If there are H plus, if there are 2 H plus, what they will do? They will repel. They will repel, so it does not exist. It does not exist. And exactly like H2O, sorry, H3O. Oxygen and sulfur are in the same group. Exact same is the situation for H3S. Yes, of course they can ask. Okay, because they're in the same group. Now, after this, the last example is what? Al2Cl6. You know how it is formed. Al2Cl6, it exists in gaseous state, but at very high temperature, it will decompose. Okay. Now, like around it exists around 200, but at 400, it decomposes. This is one aluminium chloride. This is another aluminium chloride. They combine together, making what? Al2Cl6. This is aluminium of group 3, right? It has 3 chlorine. Another chlorine. Another chlorine. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is one aluminium chloride. This is another aluminium chloride. You know what happens? This aluminium, 1, 2, 3, 4, 5, 6. There are 6 electrons. There are also 6 electrons. It needs how many electrons? This also needs 2 electrons. So you know what they do? The chlorine of this chlorine, it make a dative bond with this aluminium, and this will make a dative bond with this, like they have visible orientation. They come close in such a way that they're in front of each other, so they will overlap, definitely. Now, look, it will give electron to this and this. So, are the aluminium sharing with each other? No. This is with chlorine covalent, and here it is what? Dative. This is what? Covalent, and here it is dative. See? Now, how to make the dot and cross? And one thing more. What are the angles? 120. If you see, AlCl3 is what? 120, trigonal planar. And now, what they are going to do? Are the aluminium overlapping with each other? No. The 2 aluminium are bridged by chlorine. So, if this is one aluminium, look, this is one aluminium. I'm keeping another aluminium close, but not overlapping, right? Now, what will happen? The aluminium of the chlorine of this will overlap with the other. The chlorine of this will overlap with this way. Look. Another. This is chlorine. Look now. There is this covalent dot and cross. 1, 2, 3, 4, 5, 6, 7, 8. So what you can see? Here the chlorine is making covalent, and here it is dative. What about this one? What about this one? This one is dative. My pen is dead again. Just a minute. In this time, I'm showing the solved one. Wait a minute. I think it's in the file. Yeah. See? Look. You can see this. That how they are joining with each other. These notes are available on my website. This I'm telling you second time. You can get all the notes and all the topical on my website, but don't forget to like, subscribe, and share my channel. Right? Now, see, the one chlorine from one side it's covalent, and the other side it is dative. See, it's covalent, and here it is dative. It's covalent, and here it is dative. So how many dative bonds you can see in one aluminum chloride? In this, there are two dative. There is one covalent, two covalent, three covalent, four covalent, five covalent, six covalent. All these are your MCQs. Keep in mind. If I'm telling something to you people, keep in mind they're asked. Nothing extra. Right? Now, another thing. We have to talk about the angles and all the things, but let me explain it here. So this chlorine, it's covalent here. And it's dative on this side, right? And now these are the other two, the chlorine. Oh, I have to change the color, red. Yes, this one too. This one too, wait. Red. So what you are supposed to do? You have to draw all the dotted cross, the 8, and this is such a boring thing to make all the electrons of the chlorine. It's so huge. Top mara this. One, two, three, four, five, six. Now look. So this is covalent, and this is what dative. This is covalent, and this is what dative. So there are two dative. One covalent, two covalent, three, four, five, six covalent. And if I draw it this way, there's this chlorine making covalent and dative. These are the simple chlorines, and this is the other aluminium. This is covalent, and this is dative, the other chlorines, right? And if you see another thing, around this aluminium, one shared, two shared, three shared, four shared, or tetrahedral. This is also tetrahedral. So angles from 120 to 109. And even if you look at this chlorine, the angles are what? Two shared and two lone. See, around this aluminium, tetrahedral 109, tetrahedral 109, but around these chlorine bent to lone to share, right? And last, Al2Cl6, Al2Br6, B2Cl6, they're all possible, like group 3 and group 7. They can make such molecules. I hope you understand. You need to do the practice of all these. For notes, go to my website. And in the next lecture, I am going to explain electronegativity, polarity, and then intermolecular forces, right? Let's see you in the next lecture. Allah Hafiz.